Hi, my name is Benjamin Sturman, and these are my two teammates, Armando Camacho and Frank Azcuy. And this is our project, the Autonomous Robotic Sprinkler System. Current conventional sprinkler systems are expensive, not only to purchase, but to install. And while yes, these systems are convenient and automatic, they're often very wasteful and often leaving dry areas over your lawn. Now, a solution to this would be to water the lawn yourself, but that ultimately defeats the purpose of having an autonomous sprinkler system in the first place. So, current conventional sprinkler systems are also very wasteful. More often than not, watering the street in your driveway just as often as they water your lawn. Our goal in this is to create a cost-effective lawn care system that not only incorporates the most recent advances in robotics, but will also help decrease water waste. Now, our project objectives, as I stated before, to provide a new cost-effective autonomous sprinkler robot. A robot that will not only be able to detect the lawn that it's watering, but it will also have object avoidance, as well as know when it needs to self-dock, recharge, and do other things. And as I stated before, in order to remain as convenient as current sprinkler systems, it will have to be self-charging and it will have to be self-docking, because no one wants to be waking up at 3 in the morning every day, plugging your robot in so it'll water your lawn. Now, the first thing we thought in our literature surveys, let's find out if there's any products on the market that already does what we need to do or has aspects of things that we're trying to find. Now, one of the things that we found was called the water droplet sprinkler system. Now, this is a little robot on the left-hand side, as you see. It actually has an effective range of about 30 feet and has a really cool feature that during the day, if it has rain, it won't turn on, so it will not be overwatering your lawn. However, this one can't move itself, so we can't really call it fully autonomous. Now, we did find a robot that was able to move itself on its own called the water walker. Now, the downsides to the water walker, however, is it can only follow the path set by a hose that you lay in your lawn, which chances are if you're someone who cares about your lawn and whatnot, you want it to look nice and you don't want a hose laying in the middle of your yard every day. Now, the other downside to this is that it moves very slowly and it does tend to actually overwater your lawn, which can damage and actually kill your lawn in the end. So we decided that while these products had merit, they weren't exactly what we were looking for. What we did find that would help our cause was the current autonomous vacuum cleaners that you find in your house. And this is what we plan on basing our project off of. Now, not necessarily, the exact size and whatnot, but the features that it incorporates. And in this case, obviously, instead of, vacuuming your house, it's going to be watering your lawn. Now, we feel that these robots, some of their systems, such as their ability to memorize the patterns in a room, avoid objects that are placed there by a child or a dog laying on the floor, these object avoidances, as well as its self-docking and self-charging are things that we'd like to incorporate into our system. Finally, we decided that, well, the first thing we need to figure out is how much can our robot water based off of its battery capacity and a few other things. And so we found an equation that would let us do that. First, we thought, let's figure out how much time it takes to water such an area. And a deep watering and good care of your lawn generally requires about 1 inch of water per every square foot. So to find this, what you do is you take the area you want to water, square it, and you divide it by the required water, which in this case is 1 inch, divided by as well the flow rate. Now, we've included a chart that kind of shows the flow rate of all the different size homes, bathroom sizes and whatnot. And what happens is, in general, home sizes tend to scale with their lawns. So we feel that these water requirements and the water that was supplied will be enough for our robot to be able to water these size of lawns effectively.
Our project will incorporate the following standards: OSHA and ISO to ensure that the robot safely operates amongst their end users. IA, also known as Irrigation Association, to distribute water safely and efficiently while adhering to local regulations, and IEEE. Some constraints and considerations to take into account is that it must be lightweight and powerful enough to carry a certain length of hose. It must be able to direct the hose connection on the robot to the main base in order to prevent tangling, and it must be exposure-proof as well as be able to handle the various obstacles that it might encounter in the yard. Which leads us to our design alternatives. As previously mentioned, we wanted one of the main parameters is to avoid tangling of the rope, which is why we wanted to encompass these two separate drivetrains. The first one is the Mecanum drive system, which allows the robot to stray from side to side. It's a 4-wheel robot. Each wheel is independently powered. The issue with this is that it's very complicated, therefore making it very expensive. And also due to the design of the actual wheels, it provides less traction, which is not conducive for what it's going to be exposed to out in the yard. The second design alternative is a 3-wheel omnidirectional drivetrain system. It's a similar design to the Mecanum wheels, except the wheels are going to be angled in a certain direction. Because it has one less wheel, the wheels need to be angled in a certain direction in order to provide that strafing left to right motion, which is what we're trying to look for. Which adds to the same issue that we had with the first design alternative, which because of the design of the wheels, it's going to have less traction, which is not conducive, as previously stated. Which comes down to our third design alternative, which is pretty much our proposed design. It encompasses an iRoombot chassis, including the docking station. It's a two-wheel drivetrain system. Each wheel is powered. The good qualities of this drivetrain is that even though you're not going to get as much maneuverability as the strafing motion that you're getting with the previous two design alternatives, you are getting the added traction, which is one of the key requirements for our design. And I'm going to hand it off to Armando to talk about it in more detail.
So what Frank was talking about here was our proposed design. We're going to use the iRobot Roomba Create 2 platform. And we're going to talk about the three design components for our project. The first one being the body. It has a circular chassis so it can avoid obstacles much easier and escape from them. Not only that, we have a powerful two-wheel drivetrain. We are going to be dealing with grassy terrain, dirty terrain, so we need to have good grip on the land. We want it to be lightweight for easy support so that in the event that you do need to relocate it, it's not a two-person job. You can just pick it up yourself and move it. We're also going to include a solar-powered component to the docking station so that it doesn't really have to feed off the electricity in your home. We want this to be off-grid. And lastly, as stated before, we want this to be weather and exposure proof because it will snow, it will rain, you will have wind. Exposure is a serious topic for any robot that will be outside. So we're going to have to create some sort of platform and methods to preventing the robot from being damaged. So for the irrigation system, which is located on top of our chassis, it's going to be a rotary sprinkler head. We chose this one because it achieves the most distance for water trajectory as it flies through the air. We also are going to include this spinning base. It is going to be free from the chassis itself, so it is allowed to swivel independently. What this allows us to get is freedom of motion for the robot to do as it pleases, while still allowing the hose to always be pointing towards your water source, so now we don't have to worry about tangling. Additionally, we have a hose retrieval system, so as this robot moves and gets further from the source of water, what we have is, as it moves out, it'll give it a hose so it can irrigate the yard. And as it comes back, what we have is that it'll take back the hose, so it's not getting tangled on what was given to it to begin with. And lastly, we have the variable water valve. So let's say that your yard is too small and you have too much pressure and volume flow rate in your house. Well, we have a valve that will be variable, powered by a servo motor, so you're not over watering or shooting water across your boundaries of your yard. And here is the motion we're talking about. So as this robot moves wherever it is, we have freedom of motion for the robot, and what happens is that the swivel allows it to point in any direction. And the last component for our project is our software. We are going to have collision detection, so in the case, for children leave their tricycle outside in the yard, it will avoid it or any other obstacle. We're going to have humidity detection, just like Ben mentioned, so if it does rain, it won't double water your lawn, which could harm it. We're also going to have clip detection, so something that we can use as an analogy would be as the robot approaches a staircase, it's going to avoid that area because it will get damaged from falling to great height. So this can avoid pools, ponds, and other obstacles. And an emergency water cutoff. So in the event that it does become lodged with any obstacle, the water will shut off, because if not, it's just going to keep water in the same area for the entire time it's there, and it won't be able to return to base or anything. So it will shut off over time. So when you do come back, it's turned off and you can just relocate it easily. And lastly, in some cases, we do have end users that have several yards. So if you want to water more than one area of your home, we have multiple yard profiles with different pressures and flow rates. And design studies and simulations, we're going to be conducting a structural simulation, vibrations, because we do have the rotary sprinkler head, thermal, fluid simulations, and drop test analysis. So as you can see here, we did a thermal simulation, radiation from the sun, and convection heat transfer effects from the air to the robot. And energy consumption will also be calculated. So these are just a quick rundown of the calculations we'll be using. We have the Bernoulli equation, modified form to find the pressure loss across the hose that it gets to your robot. You want to make sure you have enough pressure to water it. And we're also chose a sprinkler angle of 45 degrees, so we achieve minimum pressure loss and a maximum distance for our water. And as been stated before, our time to water the lawn would be the area squared divided by the water requirement and flow rate. And lastly, our global design integration to our project. We are going to use multilingual user manuals, so whatever language you can use this product. We're also going to use 110 and 220 volt power sources, and universal units, so SI and US, you can use them interchangeably, and industry standard safety warnings as well. So it doesn't matter what language you speak, you can again see the inherent dangers of the robot. We open the floor for questions.
Go ahead.
As part of the autonomous functionality, are you going to have GPS or navigational drivers?
No, what we're going to have is an IR sensor located in front of the robot, which will base its location off proximity to nearby objects, as well as the wheels rotate, the robot keeps in mind where its location is relative to its docking station.
And just to, I guess, piggyback off what he was saying, as he was previously mentioned, you have different yard profiles, so the user will be able to go into there and actually pretty much pick out exactly where the robot needs to be in certain locations in order to get the full yard.
So there's a mapping functionality.
Yes, during the first time setup, we will have a function that allows you to put in, like I said before, the size of your yard. In this case, say your front yard, and you'll be able to say, we needed to water, this amount of area.
How are you going to coordinate the hose feed with the movement of the unit?
That is one of the things we've been working on the most, because we know that's going to be one of the hardest struggles, is having, a robot of decent size that's not going to harm your lawn and damage it while being able to pull a hose. As of right now, that is our preliminary hose system, which involves just a torsional spring that will be set very lightly so that we'll be able to pull it out, and as it returns, it'll come back in. But we're also looking into other possible ideas of using, very small diameter, high pressure hoses, so that it's much lighter for the robot to be able to just run around the yard with.
Yeah, but I'm thinking once that hose gets full of water, it's going to be pretty heavy to
Yes.
turn it. So we got to keep that in mind. Also, how does that Roomba drive wheel? How does that look? How does that work?
How does it?
Actually, the
how-
motors?
No, I
How
mean,
does it
what,
retract the
how do you see
hose?
the bottom of it? How is? I mean, I'm thinking you're gonna have at one point a lawn that's pretty high one day, and you're gonna, unless you're not gonna water those days that you don't need to. So how is it gonna be able to maneuver over those high grasses?
That's obviously going to be part of our testing, is to see how large of a wheel we're going to have to require. Obviously, like we said, this iRobot 2 Roomba chassis is going to be the basis for our comparison. We might find that we need to scale up, we might find that we need to use larger wheels along the line.
Yeah, I'm thinking external wheel. That's why I was asking you, how is that Roomba wheel?
We were talking about, we do not plan to have the wheels directly under it, as that will restrict the size to, my fist, which, like you said, if you get a lawn any larger than this, your wheels are just going to start spinning.
Right, and
So we
so
plan to expand it to some degree.
that's what I'm saying. But that's why I was asking you, how is it originally the Roomba drive is? Because if you're able to put those wheels on the outside of the chassis, and
Yeah,
they're
that's
bigger,
what
you can control the height, and it'll be a lot easier that way for you.
We plan to make modifications. We're going to 3D print the wheels, so we have a little more versatility. And it's a modular chassis, so we could make changes to it.
Yeah, the reason why we chose this one is this chassis specifically designed for home,
Making
tinkerers,
alterations, yeah.
that you'd be able to, expand the shaft sizes if you want, move it outside of the chassis, and
Right,
upgrade
right.
the motors if you feel they need to be stronger for torsion and whatnot.
And what about the cost analysis on this? How would it compare with something else that's available out there, like just having to move it around yourself, or having actually a static system, a stationary system where you have the pipes running around and waste some water, but a lot of times people use well water for that, so
Yes.
they don't get charged for it. But you done any numbers at all or anything?
No, but we'll definitely take that into consideration for our next presentation.
Yeah, sure.
Okay. My question goes back to your motivation about decreasing water waste.
Yes, sir.
How do you know that your sprinkler system is going to decrease water waste as compared to other sprinkler systems?
Okay, so it's pretty often you'll be walking outside and you see this conventional sprinkler system, even here at FIU in the parking lot in this campus. The sprinkler systems are actually watering half of the time on the street. So right there, that's water wastage we could already prevent.
But how do you know that yours
So what
is
we're going to do is we're going to program the robot. Once it knows its effective watering diameter, we're going to set it so it never approaches the boundary. So it'll always be inside the area to be watered.
And like we said before, when you have your lawn profile saying, in most cases, your lawn's gonna be a square shape or a rectangle. You will obviously have the diameter you feel is best for your lawn size. Say you have a yard that's, 40 feet, you wanna have it, your diameter be, or your radius, or actually no, your overall diameter, you want it to be 20 feet. And so you tell the robot, what you're gonna do is you're gonna make 2 passes. It's gonna go along one half of the lawn, exactly the width that it needs to be. And like we said before, that time calculation, what that'll do is that'll only water the lawn exactly the 1 inch that it needs. And piggyback on what he said before, I've walked out to my car and I've gone to walk through the lawn just to, take a quick short step, and my foot sinks to, almost my ankle in water, because these, they say, oh, we're a large area, we need industrial size sprinklers, and they have, so much water that you could grow crops with them, and they're just wasting, this much water. Like we said, we need 1 inch of water, and that's what our robot's gonna incorporate, only giving the amount of water that's needed and where it's needed.
Considering that most homeowners are novices in terms of programming robots and these kinds of devices, what are your strategies with respect to designing and providing O&M manuals for all aspects of the operations of the robot, including periodic maintenance and all of that, just to make sure that it's always working and functioning properly?
So what we want to do is use a UI-friendly program for the consumer. So
That is also global.
That is also global, so we will have to have several languages, or maybe we can use a picture-based UI where it's just, you see a picture of it, saying to water, go, so green, we could use colors as well to kind of, facilitate the end user's experience with the UI. And the UI is a user interface, just depending on the user.
So far, it seems like you have a good flow going on. You've thought a lot of things out, which is good. I do have a question, 2 questions, because you answered the third on maintainability. So I assume you're thinking on properties that are flat. What happens in different parts of the country, let's say if you were to actually think it through, and what happens to places that have really bad slopes? Like lawns
California.
that slope down. Well, I live in Florida, and there's places where I live where the yard does this or does this.
Okay.
And so what happens when your little robot is like, okay, I'm flat, oh no. Does it tip? I mean, are you gonna be able to have something for that? Have you thought that
I
through?
guess we can make changes to the wheels to include maybe better grip, so that in the event that you are going up a slope, it has the grip that you need.
Okay.
And then in terms of sharp drops, we could make a few modifications, maybe make the robot larger so it doesn't have that tipping.
Just be aware of that, because I know that for flat land, that's fine, but
Yeah.
what if it's not?
Okay.
And I do have a question on a range. You're saying you want to decrease the waste with water. Some homes are not just a rectangular shape. You have
That's fine.
homes that are, people make them funky looking,
Pie shape.
Yeah. And sometimes, they put the driveway, not in the side, like, they put it more to the side, and so you have more lawn on one side and a smaller lawn on the other side. So how do you not waste on that portion where it's just a small strip?
Well, like we said before, you can have different yard profiles, and in this case, I do have that in my own house. We have one half is the majority of the lawn, and then there's about a 6 to 8 foot section on the other side of the driveway, in which case, like we said before, during the initial setup, obviously, like you said before, there's going to be a lot of different aspects we're going to have to take into account while programming, but possibly you might be able to add in where your driveway is, where a large obstacle is, so that your robot doesn't just have to use, the near field communication or whatnot to actually avoid it. But in this case, you could have it say, and that's also why we have the water valve that can decrease the flow. Say the main portion of your yard is rather large, so you want a large diameter, so you're not wasting water or time and battery life trying to water with such a small diameter. You can have it move over to that smaller section, trim down the amount of water, so now your effective range is decreased. You can run that path and then return.
It would be doing that using the variable water bulb, which would be connected to the onboard electronics, telling the robot, look, you're in a smaller area now. Let's close the bulb a little bit so we can decrease the effective range.
Then you have to modify your time as well in the area.
Yes.
Absolutely.
So then we'll have
Yeah,
added
something
terms on
like-
the equation.
Would it water 360 degrees? Or-
Yes, the
Yes.
sprinkler head rotates
Yeah.
complete 360 continually.
So how do you deal with trees?
The trees, so the front of the robot does contain an IR sensor, so it'll see that there's a tree in front of it.
Yes, but you've got geometry then.
Or do you mean
You've got-
as a blockage for when it's watering, what's behind it won't be getting watered?
No, by getting your hose stuck around it.
That's,
So I guess we'll have to
Mhm.
include some sort of exception in the programming where in the event of a tree, it's gonna have to, it's not allowed to
Back up.
just circle, it's gonna have to back up.
I was gonna say, in that, like you were just mentioned, go up, come back, go around the tree.
Yeah, because this robot won't travel too much because it's watering over a radius, so it doesn't have to move as much as, say, traditional robotic vacuum cleaner. It just has to reach certain points in the yard and that's enough for it.
And also keep in mind, you have a small window of time for you to water your lawn. So
Exactly.
you gotta see how long that's gonna take to water your lawn, because the thing is, you don't wanna water it, in the middle of the day where you're wasting
Yeah,
the
we did a
water.
little bit of research.
Plus, you don't want to, because you'll burn your grass, so you wanna do it early morning or late evening, but you don't wanna go late at night either.
Yeah.
So you're gonna have to keep that in mind,
Yeah.
Mhm.
Maybe use two of them.
We were thinking that for the front and backyard, as having a robot that travels all the way around the side of your house would be
Yeah.
Yeah, it'd be a little trouble.
quite tricky.
Could I see two things, please? The engineering standards slide and the division of labor slide.
So sorry.
Okay. What about the division of labor slide?
So our division responsibilities, we did have it initially, but we felt that it would take the crucial time we have 10 minutes away from what we really want to get to the end.
No, I meant for the project, not for the presentation.